Hello, welcome to ATG 4950. Once you build a product, it should be tested before you release it to the market. The product should be tested for functionality and performance. Designers and developers should plan for testing, and representatives of users will be selected to try the product and provide a feedback. Methods of testing will be determined. In this chapter, we will address product testing and evaluation, and the chapter will include the different testing methods, their applications and objectives, in addition to some of the tools or methods within each type of testing will be also presented and discussed. The product survey and customer feedback ensured that the product is acceptable to the one who shall use it or to the market. The product has to be within the preferences of the target market. Otherwise, the product will not sell. So you need to make sure that it is within acceptable range for the market. We used the customer survey to come up with different product specifications, and in this chapter we will be learning about testing methods for these specifications. But before that, let's define product testing. Product testing is a measure performed to determine the functionality, reliability, durability, usability, safety, and efficiency of a product. It's an important process, but unfortunately the most tedious and expensive part of the whole research and development process. For this one, we need to take many points, many data points, and lots of iteration until we make sure that the product is acceptable for the market. So it's tedious, yes, and expensive, but must be done to make sure that it's been released to the market with the functionality and efficiency and effectiveness that will be required, not only for the market but also to compete with other products in the market. Some of the major testing methods that can be identified are the non-destructive testing, this is a wide group of analysis techniques that is used in science and technology industry to evaluate the properties of material, components, or system within or without causing damage. Also, it can be identified as the process of inspecting, testing, or evaluating materials, components, or assemblies for discontinuities or differences in characteristics without destroying the serviceability of the part or system. The other type is called destructive testing, which is a method of testing that will be put or that will put the sample under certain circumstances until it actually fails, and we will be looking at some of the like functionality testing or hardness testing for this type of test or for the product. And when we say functionality testing, means we are trying to verify whether the product meets the intended design specifications and functional requirements that we developed for that product. And we'll talk about the functionality testing at a later slide. The Center for Non-Destructive Evaluation at Iowa State University listed some of the applications for the non-destructive testing. First, screening and inspection of incoming material. You can use it for that. You can use it for product development. You can use it for inspection for in-service damage, for verifying proper processes, for monitoring and controlling manufacturing processes, and for verifying proper assembly. And as been stated here, for product development, since we are designing a product, new product, then we can use it for the product development testing as non-destructive, and we have just a prototype, maybe one sample that we need to work on and make sure that it's functional as needed. So we don't want to destroy it, and that's why we use non-destructive testing for our samples or for our units that we created for the product. The objective of the non-destructive testing, as suggested by the American Society for Non-Destructive Testing, is to ensure customer satisfaction through ensuring product reliability and integrity, and to ensure the safety of that product to the end user, and to compete within the currently evolving market by maintaining a reputation through high quality products and better product design. And of course, to minimize waste, so we are working also on the environmental side, but also it will lead to minimizing the overall manufacturing costs and maximizing the profit, even when we look at the environment as a waste. So it's not only for the environment, it's also good for the company, and this is something that has to be addressed, and to make sure that, you know, they understand even using the environmental safe product that will save the company in the long run and maximize the profit. And then to ensure the flexibility and adaptation of products to the market changes. Based on the National Material Advisory Board, there are 6 major non-destructive testing methods that has been identified: visual, radiation, magnetic, electrical, mechanical vibration, thermal, and chemical, electrochemical. And again, those are the most, you know, you will see lots of other testing that are listed or that's available online, but again, those are the most common. And if you need to add custom-made test for your product, then you can do that too. So this is not set in stone. This is just an example of some of the common tests that's available. The visual method is the oldest and the most common method, where it involves the visual observation of the surface of a test object to evaluate the presence of surface discontinuities such as corrosion, misalignment of parts, physical damage, and cracks. The visual test inspections could be done through direct viewing, just by looking at using your eyes at the product to discover any discontinuities, or could be enhanced with the use of optical instruments such as magnifiers, mirrors, periscopes, charge couple devices, and computer assisted viewing systems. In the radiation method, an X-ray machine or radioactive isotope is used as a source of radiation, which will have the ability to penetrate the object under testing, showing cracks and other defects. The results will be recorded onto a film that can be developed into a radiograph showing those defects. The problem that X-ray can affect the health of the people performing the test. For the precautions and policies, precautions and policies must be followed in order to protect testing engineers and technicians. The radioactive waste should be also taken into consideration for environmental and biological reasons. The figure in this slide shows an X-ray that has been taken in a manufacturing environment that shows the crack or the opening in a tube. The eddy current is a type of electromagnetic non-destructive testing method in which electrical current is generated in a conductive material by an induced varying magnetic field. The variations of the object are reflected into a nearby coil. This type of testing can be used for detecting surface cracks and to make electrical conductivity and coating thickness measurements. This method works only with conductive material, and the surface of the metal must be accessible to be able to do that testing. If you cannot access the surface, then you will not be able to do such a test. The magnetic particles testing uses one or more magnetic fields to locate surface and near surface discontinuities in ferromagnetic materials. So the material that we are testing should be ferromagnetic. If it's not ferromagnetic, this magnetic particle testing will not work. The magnetic field can be applied with a permanent magnet or an electromagnet, a magnet that's being generated, or a magnetic field that's being generated by electricity. When using an electromagnet, the field is present only when the current is being applied. When the magnetic field encounters a discontinuity, a transverse to the direction of the magnetic field, the flux lines produce a magnetic flux leakage field of their own, as shown in the figure, and you can see the leakage of these magnetic particles, which will show the problem with the surface. The magnetic particles may be dry powder that you can use, or suspended in a liquid solution, and they may be even colored. You can make them color with a visible dye or fluorescent dye that fluoresces under an ultraviolet light, so you can see the crack clearly. Another well-known test is the mechanical vibration test, which is an ultra high frequency sound that's introduced into the part being inspected. If the sound hits a material with a different density and acoustic velocity, some of that sound will reflect back to the sending unit and can be shown on a visual display to display the cracks in the unit. By knowing the speed of the acoustic velocity and the time required for the sound to return, the distance to the reflector can be determined and cracks will be detected. The liquid penetrant method of testing is used to detect surface breaking flaws in any non-absorbent materials. The basic principle of liquid penetrant testing is that when very low viscosity liquid is applied to the surface of a part, it will penetrate fissures and voids, and that will show any of these fissures or voids that is closer to the surface or open to the surface. Once the axis penetrant is removed, the penetrant trapped in those voids will flow back out, creating signs of breaking or cracks. Penetrant testing can be performed on magnetic and non-magnetic materials, but does not work well on absorbent material. So again, with having the choice of magnetic, and the magnetic will work on ferro material only, then with the liquid penetrant, actually it can work on both magnetic and non-magnetic. And if you are dealing with absorbent material, then the liquid penetrant will not work, so you need to use the magnetic if it's ferro magnetic material. The choice of the testing method will be based on the product, based on the material used in the product, and based on the specification of that product. The other test that we said was the destructive test, which are often used to determine the physical properties of materials such as impact resistance, ductility, yield, and ultimate tensile strength, fracture toughness, and fatigue strength. The destructive testing is used in metal testing, for example, testing the strength of welded parts or other metal characteristics by stretching or by putting tension on bending parts or on welded parts. So we can bend it, we can stretch it until it breaks, so we can see that it holds or not, or to what limit it can hold before it breaks. This type of testing is commonly used in automobile manufacturing testing, where they crash the car from different angles and check on the level of protection that will be provided for the users of or the car or the drivers, in addition to the different functions that is needed during such an incident. Another example will be testing a cell phone for its resistance to water damage. If you claim that your cell phone is resistant to water damage, then the phone can be immersed in water at different depths and for different periods of times to make sure that it will not be damaged or until it's damaged. And that will be also a destructive testing if the phone got damaged. The most common destructive testing methods are the tensile tension or testing, the force testing, and the hardness testing. The tensile testing or tension testing of metals is a destructive test process that provides information about the tensile strength, yield strength, and ductility of the material. A variety of equipment can be used to test specimens in all sizes, from small fasteners to large tubing and welded parts. The sample is subjected to a controlled tension until failure. Properties that are directly measured via a tensile test are elastic limits, stretching, modulus of elasticity, proportional limits, reduction in area, tensile strength, yield point, yield strength, and other tensile properties as needed. Again, you can do it as custom as you need based on the product and product specifications. For the force testing, the force testing includes free bend testing, which is designed to measure the flexibility of weld deposit and the heat affected area adjacent to the weld. And then we can do guided bend testing, and that's a test used to determine the quality of the welded material or metal at joints. To pass the test, the sample object has to be bent to 180 degrees with no cracks on the surface greater than 1/8 of an inch. The neck break testing is used to determine the internal quality of the weld material or the welded material. It will detect whether internal defects exist, such as slag inclusion, gas pockets, lack of fusion, and oxidized or burned metal. Impact testing is used to measure the ability of the weld to absorb energy under impact without fracturing. It's considered a dynamic test in which a test specimen is broken by a single blow. It's useful in finding out whether any of the mechanical properties of a base metal were destroyed by the welding process. And the last one is the crash testing, is performed to ensure safe design standards in crash compatibility, as we stated in the example of the car. Hardness is used to evaluate materials properties such as strength, ductility, and wear resistance. Hardness test is a testing method or for testing the material resistance to bend, scratch, abrasion, or cutting. Relative hardness of minerals to resist scratch, for example, can be assessed by reference to the Mohs scale, which is a rank or it ranks the ability of material to resist the scratch by another metal. Then we have another hardness test, which is called the Bernal, which is a type of hardness testing that is based on applying forces on an object using a steel or carbide ball. The Bernal hardness test or hardness number is calculated by dividing the load applied by the surface area of the indentation. Compared to other hardness testing methods, it makes the deepest and widest indentation, which will make it more accurate. The Rockwell test is also a test that applies force on an object to create indentation, but using a diamond, cone, or hardened steel ball indenter. One of the advantages of Rockwell hardness method that it includes the direct Rockwell hardness number readout and rapid testing time. So you can read from the tool that you are using the indentation that happens to the metal. The disadvantages include many arbitrary non-related scales and possible effects from the sample object. Another hardness test is called the Vickers hardness test that was developed as an alternative method to measure the hardness of materials. It does not have the arbitrary non-related scales of the Rockwell method, and it's easy to use more than other hardness tests. It can be used for all metals and for ceramic materials. The advantages of Vickers is the extreme accuracy reading obtained by this test. It's thoroughly adaptable and very precise for testing. The one that we have on campus or at school is the Bernal testing device and testing method. The Microhardness test for metals or actually a testing of metals, ceramic and composites is useful for a variety of applications where other test methods are not useful. For example, it's used for testing very thin materials like foils. So the microhardness testing gives an allowable range of loads for testing with a diamond indenter. The testing done similar to Vickers test, but on a microscopic scale with higher precision instruments. So that will be all for the first part of the testing method, and if you have any questions, please let me know. Thank you and have a great day.